In the last session, we talked about decision trees, and I put a video in the Darsa site about the decision tree uh, and how to build a decision tree. We said that a decision tree is a classifier which the learning model is a tree. The learning model is a tree. This means that the relation between the inputs and output is done using a tree. Okay, then we said that when we want to build this tree, in this tree there are two types of nodes. Some nodes are internal nodes like this one and this one. Inside these nodes we have some features, and in the leaf nodes, these nodes, the leaf nodes, we have the classes of our data. Okay, and I said we have many different decision. Sorry. Is my voice good? Okay, thanks. We have many different decision trees, and we talked about the ID tree, decision tree, and we said that in a decision tree, one of the most important things is how to select the best features to put them in the tree. In the ID tree decision tree, the features are selected using the information gain, and we have to calculate the information gain for the features, and the feature that has the maximum information gain would get into the tree. Okay, and we said that in the information gain, it is based on entropy. This was the formula of entropy. We could, and this was an example. We talked about how to calculate entropy, and in this example you see that we could calculate entropy using the output of our data. The entropy is calculated using the classes or the outputs of our data. In this example, you see that the output is this, play tennis is the output, and the value of the output is no or yes. No here it means negative, and yes means positive. So in this formula you see that we have calculated the probability of positive data, which is 6 divided by 8, because we have 8 data, and from this 8 data 6 of them are positive or yes, and the probability of negative is 2 divided by 8. So the entropy would be 0.2. And um, you see that we said that entropy is a value between 0 and 1. The best value for entropy is 0. It means that all of the data have the same class. And the worst value for entropy is 1. It occurs when we have the same number of instances in all classes. Okay, and then we had we talked about the information gain. If we want to calculate the information gain of an attribute in the data, we could calculate the information gain using this formula. If we have a data S and we have an attribute A, the gain of this attribute in this data is equal to entropy of the data minus the entropy of the attribute. Okay, and we had an example here of how to calculate the information gain of the feature wind in this data. Okay, the information gain of feature wind in the data S, it was calculated in this example. We said that we have to get the values of the feature. The feature wind has two values, weak and strong, and for each of these values, see how many positive and negative data we have. Okay, we get this data. Okay, first in the whole data S is all of the data. Here here we had 14 data. S is all of the data. In all of the data we have 9 positive examples and 5 negative examples. And then in the data which the feature wind is equal to weak, we have 6 positive and 2 negative. Okay, and also for when the feature wind is strong, we have 3 positive and 3 negative. Okay, using this data that we have here, we calculate the entropy of S. Okay, using the same formula we said in the previous slide. And then we calculate the entropy for each of these values of feature wind. Okay, and this is the gain. This is the gain of feature wind. Okay, that was what we said in the previous sessions. And then I put a video in last week. I put a video about how to build the decision tree, and this was the final subject I talked about in the decision tree. Okay, Mr. Bassett, you said when the profit information gain is inappropriate, do we change the features? Okay, you say that yes, we could change the features. Okay, but finally we get a group of features, and then we want to use that features to build the tree. Okay, but information gain could be used as a metric to say which features are better. So we could use it for selecting the best features. Okay, but finally in this decision tree, ID tree, we use it for building the tree. Okay, I talked about the algorithm for building the decision tree ID tree in the last video. Did you see that video? Okay, very good. Okay, so I will just review what I said in that video, and then I will go to the next subject. If you have any questions, ask. This was the algorithm for building the decision tree. In this algorithm, okay, we have a function id tree, and we have two parameters, examples and attribute. Examples are the data that we are using currently to grow the decision tree and add a node, and attributes is the current attributes we are using for building the tree. Okay, uh, the first thing we do in the id tree algorithm is that we create a node. Okay, we create a node, and then we check some conditions. We say that if all the examples are positive, okay, if all the examples are positive, we say that the node we created is a leaf node and the label is positive, and we end the the tree in that node. Okay, or if all the examples are negative, we say the node that we created is a leaf node. Okay, and the label is negative, and we end the decision tree in that point. Okay, so when uh, 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 we are building the decision tree, we may come to a situation where all of the data have the same class or label. Okay, in that situation, we have to put a leaf node. A leaf node is a node that inside it we have a class, and we end the decision tree in that point. These two conditions are related to this. Okay, in this algorithm we are assuming that our data has two classes, positive and negative, but generally the decision tree could handle data with more than two classes. Okay, the third condition say if the attributes are empty, then again we have to put a leaf node, and we can't grow the tree because we don't have any attributes. For example, in the example that we had about this example, okay, uh, in this example we have four features: outlook, temperature, humidity, and wind. So if in our decision tree uh, we have four nodes that are the parent of each other. Okay, if we have four nodes that we have that are the parents of each other. For example, outlook is the parent, then we have temperature as the child of outlook, then we have humidity as the child of temperature, and then we have wind as the child of humidity. Okay, if we have this situation, then we have used all of the attributes in the tree, and we don't have any attributes left, so we can't grow the tree anymore, so we have to stop it. And this condition tells us to do this. Okay, do you understand this? Okay. Okay, look at this example here. Okay, look at this example that we had here. In this example, our data has four features: color, shape, size, taste. Okay, in this example, our uh, our data uh, has four features. Okay, color, size, shape, taste. Okay, no problem. Okay, in this tree, you see that in this. Okay, here we have color in the root node, then we have size here, then we have taste. Okay, so you see that in this branch of the tree, free of the attributes are used: color, size, and taste. Okay, so in this uh, branch of the tree, free of the attributes are used. If for example we had another attribute here and it was shape. Okay, so you see color is the parent of size, size is the parent of taste, and if we had another a node here for the attribute shape, and shape was the child of taste. Okay, if we had this situation in this example, then all of the attributes are used. Okay, we have only four attributes. All of them are used in building the tree. And after that, we don't have any attributes because the parent and the child could not be the same. Okay, if we have color in the parent attribute, we can't have it in the child's of that node. Okay, do you understand? Okay, assume that we have another node here. Okay, and this node is shape. Okay, in this example we have another node here, and this node is shape, and it is the child of taste. Okay, we don't have this, okay, and assume we have this situation. Okay, so the size is the child of color. Okay, Mrs. Hoda, the child the node size is the child of color, the taste is the child of size, and the shape is the size of taste. After this, here, after shape, here we don't have any attributes. All of the attributes are used in this branch. Okay, in this branch of the tree, all of the attributes are used. All of them are parent and child. Okay, so we don't have any more attribute, so we can't grow the tree anymore. Okay, do you understand, Mrs. Hoda? Okay, so this, but okay, here in this situation, okay, here we have only color and size. and the next node, it could be shape or taste. No problem. But in this branch, we don't have any attribute. Okay? In every branch, it's different. In every branch of the tree, it's different. In some of the branches, the attributes are finished and we don't have any attribute. But in some of the branches, we can grow the tree. Okay? It completely depends on the data that we have, on the training data that we have. We are building the tree using the training data. Okay. So this is the condition that we have in the algorithm that says if the attribute is empty. Okay, we will come back to this later on. Okay, if all of these conditions are not true, so all of the data are not positive, all of the data are not negative, and the attributes are not empty, all of those conditions are not true, we come here and then we say select the best attribute in the current situation based on the examples, the data that we have. You see, we calculate the information gain for the attributes that we have in the current situation in the tree, and then we select the best attribute which has the highest information gain, and we put that attribute in the tree. Okay, and we add some branches which are the values of that attribute. Okay, okay, let's see this in an example here. Okay, let's see this in an example. Okay, again, in this example, this is the data that we have. Okay, this is the same data, 14 data for tennis, and in this data we have 4 features: outlook, temperature, humidity, and wind. And this is the output. Play tennis is the output. Okay, let's see what I said in the example. Okay, in the first, okay, we want to build the tree using this data. Okay, in the first step, we go in the algorithm, and the algorithm says, okay, are all of the data positive? Okay, what is the answer? No, because okay, you see that in this data we have positive and negative. Okay, and again, all of the data are not negative. So the first two conditions are not true. And the third condition, is the attribute empty? No, we have 4 attributes: outlook, temperature, humidity, and wind. This is the we want to start to build the tree. So none of those conditions are true. We go to the next step and we calculate the gain of all of the attributes. And then we select outlook. Outlook is the best attribute here. It has the highest information gain. And we put outlook in the root node of the tree. Okay, you see that? We put outlook here in the root node. That's what we're doing in the next step. And then we put the values of outlook here: sunny, overcast, and rain. These are the values of outlook. We have put them in the branches of outlook. Okay, no problem here. So we selected the best attribute, we put it in the tree, and then we added the branches of that node with the values of outlook. when we are building the tree in each, okay, here, this was the first node of the tree outlook, okay? And now we have to check these points, okay? Here, when outlook is sunny, again uh, we check this those three conditions, okay? And if those conditions are not true, we select the best attribute. So uh, so we are selecting the best attribute in every node of the tree, not only for the root node, Mrs. Hoda, okay? We are checking for the best attribute in all of the nodes that we are adding to the tree. Okay? Okay, so this we added the branches of the node outlook. The node outlook, it has three branches because it has three values: sunny, overcast, and rain. Okay, so we come to this situation. We have a node here and we have three branches. Then we come here. Okay, uh, we want to grow the tree in this point. In this point, outlook is equal to sunny. Outlook is equal to sunny. Okay, so when outlook is equal to sunny, in the data that we have here, we only select the data which outlook is sunny. Okay, so it's data 1, data 2, data 8, data 9, and data 11. Only 5 data outlook is sunny. So, okay, we check these 5 data only, not the rest of the data, because in the rest of the data the outlook is not sunny. Okay, so in this data we say, are all of the data positive? Okay, we check it. Here we have 2 negative, here we have 1 negative, 1. So all of the data are not positive, all of the data are not negative, and we have 3 attributes. Okay, here in this point we have 3 attributes. The attributes are temperature, humidity, and wind, because outlook is used in the root node. The attribute which is used in the root node could not be used in the rest of the tree, because all of the nodes are the childs of the root node. Okay, no problem. Okay, so here between humidity, temperature, and wind, we select, again we are calculating the information gain between these 3 attributes: temperature, humidity, and wind. And we see that humidity has the highest information gain, so we put it in this node. Okay, the calculations are not, I have not put the calculations here. Okay, Mr. Ali Asif, you said that we take the attribute one time only. For the root node, yes, but for the next node, no. For example, we may have humidity here, okay, and also we may have humidity here. It depends on the information gain. Okay, if the attribute is in a parent node, it could not be in the child nodes. Okay, for example, when we have humidity here, we can't have it in the childs of humidity. But if we have both, but we can have humidity here, because this node is not the child of this. Do you understand, Mr. Asif? Okay. Okay, so in this point of the tree, we selected the humidity because it had the highest information gain in the data which outlook is equal to sunny. Okay, so then these are the two values of humidity, high and normal. These are the two values. Okay, you see in the data high, normal. These are the two values we have for the feature humidity, high and normal. Okay, and these two values, okay, we put them in the branches of the tree. Okay, and okay, so we come here into this situation. Okay, when we come here and we want to grow the tree, again we are checking the conditions, the first conditions. The first condition said, is all of the data positive? Okay, we check in the data. The outlook is sunny, the humidity is high. Okay, the data which outlook is sunny and humidity is high. If you check in this data, okay, outlook sunny and humidity high. Okay, these the first D1 and D2 are like this: outlook sunny, humidity high. Okay, we say that play tennis is no, so it's negative. In this one, sunny, uh, it's again high and it's no. Here it's sunny, but this is normal. Okay, sunny, normal. Okay, so all of the data which outlook is sunny and humidity is high, the label is negative. So here, that condition that we had in the start of the algorithm, okay, this was the condition. This condition, okay, is all of the data negative? We say yes, all of the data are negative. So what do? We put here, we put a leaf node and we finish the tree in this point. Here we put no. This no is a class of our data. Our data has two classes, yes and no. Positive, negative, okay? So we put a no here and we don't grow the tree in this point, okay? We stop the tree here. Okay, do you understand this? Okay, very good. Again, we have the same situation when the outlook is sunny and the humidity is normal. Okay, all of the data are positive, so we put a positive here and we finish the tree in this point. Okay, so in the branch which outlook is sunny, we have grown the tree and we have finished it. So we go to this branch, outlook is overcast. Okay, we check in the data. The first condition said, is all of the data positive? Okay, we look here, overcast, outlook overcast. Okay, we see here it's positive. Outlook overcast, it's positive. Outlook over, all of the data which outlook is overcast, the label is positive, so we put a positive here. We put a yes here, okay, and we put it here, and we finish the tree in this branch. Okay, so in the branch where outlook is overcast, we don't have any other nodes and we only have a leaf node because all of the data is positive. Okay, and this is what happens. Again, in the next branch, outlook is rain. We check in the data. Okay, outlook is rain. All of the data are not positive and negative. If we check it here, okay, D4, D5, D6, you see two of them are yes, one is no. So all of the data is not positive and negative. Again, in this point, we have three features: temperature, humidity, and wind. So we calculate the information gain of these three features: temperature, humidity, and wind, and we select the best feature. Uh, and the best feature is wind here in this situation. In the data, okay, in the data where outlook is equal to rain. Okay, so when we want to calculate the gain, we are calculating it only in the data which outlook is equal to rain. Okay, it's 5 data: D4, D5, D6, D10, and D14. Okay, so wind is selected as the best feature in this point, and then wind has two values: strong and weak. Again, for these two values, if we check in the table of data, when the outlook is rain and the wind is strong, all of the data is negative, so we put a no here and finish the tree in this point. And the same thing happens when the outlook is rain and the feature wind is equal to weak. All of the data are positive, so we put a positive here. Okay. Uh, so all of the tree is finished. All of the tree is finished, and you see it here that what we did in building the tree and what happened. If you have any questions, please ask me. Okay. Okay, Mr. Asif, you asked that how do we choose the root node? Okay, the root node doesn't have any difference with other nodes. We do the same algorithm. Okay, the same algorithm is done for the root node. We just do the same algorithm, and we uh, calculate the information gain, and the feature which has the highest gain is put in the root node. Okay, so it's not different. The same algorithm is done for all of the nodes. I said that the ID tree, the decision tree, it is a recursive algorithm. It means that the same algorithm is done for all of the nodes. No difference between the nodes. Okay, Mrs. Hoda, you said that why not use attribute temperature? Yes, the attribute temperature is not used because it depends on the data, you know? It depends on the data. Uh, uh, the data that we had, we didn't need the attribute temperature based on information gain, okay? Because the information gain of the attribute temperature was less than the other attributes. So we didn't select this attribute, okay? and we didn't need it. Okay, Mr. Malek, you say, why did we choose wind? You mean here, in this point, you mean? Mr. Malek, do you mean wind that we put it here? Okay, because it has the highest gain between the attributes. In this point, we have three attributes: temperature, humidity, wind, because Outlook is used before, okay? And this is the child of Outlook, so we can't use Outlook again. So we have three features: temperature, humidity, wind. The gain of wind is higher. That's why we use it. Yes, Mrs. Hoda, temperature is not used because it has a lower gain. Okay. Okay, Mr. Mustafa, you say what is the reason for using temperature? Okay, it's in our data, you know. Our data has four features. Our data has four features, and uh, we have temperature in our data, and it has four features. Okay, so but it wasn't used in the tree. Okay, but it is a feature. If if for example our data was different, maybe temperature was used. The best attribute, Mr. Ms. Hussein, the best attribute is selected using the information gain. Okay, the information gain, it was here. We talked about the information gain. This was the formula of information gain. Okay. 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 I This topic about the decision tree is finished here, and we talked about decision tree. It was a classifier which we can use. Uh, One of the most important advantages of decision tree is that we could use decision tree in the data which the features are categorical. Uh, Categorical means the features are not numbers; they are string values. For example, here you see color is green, yellow, red. It's not a number. So we could use the decision tree for this type of data when the features are not numbers, but still we could use decision tree for data which the feature are numbers too. No problem, we could use it, okay? So we could use decision tree in data where the features are numbers. No problem, we could use it, okay? Okay. One other point about the decision tree is that this tree is very simple. This classifier is very simple and everybody could understand what is it doing. Okay? Everybody could understand what the decision tree is doing. For example, if we are building a decision tree for classifying an illness, okay, to say if is this patient ill or he is not ill, we could build a decision tree, and then we could show this decision tree to a doctor, and the doctor could uh, understand what it is doing. Okay, so the decision tree is has this advantage that it is understandable by people who are not data mining and who don't have any information about data mining. They could understand what the decision tree is doing. Okay, after we have built the tree, we could show it to uh, different people and they could understand what is it doing. It's different from the neural network. The neural network, okay, nobody could understand how it is working. Okay, the neural network is like a black box, and inside it, it is a complex learning model. But the decision tree, the learning model is a tree, and everybody could understand what this tree is doing. Okay, so we talked about the ID tree, decision tree. If you have any questions about that, ask me. Thanks. Uh, if the data, if our data is numbers and it is not categorical values like this data that we had here, okay, uh, we said that this categorical, it means that it is a string values and the number of values are limited. For example, the color feature, it has three values in this example, okay? Green, yellow, and red. Okay, so the number of values are limited. But if the feature is a number and the number of values are not limited and it is unlimited, okay? Uh, okay, if we have this type of data, that most of the data that are using numbers, they're like this, they don't have a limited number of values. In this situation, uh, in this situation, um, we have the decision tree converts the data, and it converts the data to discrete values. Okay, if the values are continuous and the number values don't have a limited number of values, it will convert it and it will partition the data. This would be done by the decision tree, okay? Because if the feature has an unlimited number of values, in the tree the node will have an unlimited number of branches, which is not capable for the decision tree. Okay, we can't have unlimited number of branches. So these features are converted and they are partitioned and they are converted to discrete features. That's what happens. For example, it says that if we have a feature like, for example, age is a feature which has an unlimited number of values. Okay, so we say age is bigger than 20 and age is smaller than 20. Okay, so we are converting it into two values. Okay, do you understand, Mr.? That's what is doing uh, what is done in the decision tree. Okay. Okay. Again, I want to remind you that at Tuesday we have the midterm exam at uh, 12 o'clock. We have the midterm exam. Sorry, the time of the exam is, let me check it, is 12:40, I think. The time of the exam. Yeah, no. The time of the exam is 12 o'clock until 12:40. Yes. I said that the uh, the questions of the exam, most of them are multiple choice. Okay, most of the questions are multiple choice. So you have to read the slides. The first slide about classification, and the second slide about the neural network. Okay, uh, the the neural network, it had two parts, part one, part two. Okay, okay. So so you have to read those slides. Most of the questions are multiple choice, and I said we will have one question which you have to write a solution, and I gave you a sample in the Darsa site. Okay, I gave you a sample in the Darsa site, so check that sample. Okay, The question of the exam will be the same, will be something similar to that. Uh, it will be something similar to that. Okay, no problem. You won't have, you will have enough time. No problem. Don't worry about the time. I give, I will give you enough time because most of the questions are multiple choice. Okay, most of the questions are multiple choice. No, I will, for the perceptron, I won't give you a very long question. Don't worry about that, okay? Don't worry about it. Okay, thank you. Okay. Okay. Uh, the next subject I will talk about it is regression. Okay. The next subject is regression. Regression is a type of learning that we have in data mining. Okay. In the previous slides, we were talking about classification. All of our talks were about classification. Okay. Uh, and we talked about the neural network. We talked about the deep learning convolution neural network. We talked about the decision tree, and in the video I put for you, I talked about the KNN classifier. Okay, I talked about these different classifiers. All of them were classifiers. In the classification, the data that we had, it had the outputs of the data, it was discrete. Okay, the number of outputs were limited and it was discrete. Okay, this was the classification. Okay, the next type of learning that we want to talk about very shortly is regression. The regression is very similar to classification. The only difference is that the output of our data is not discrete and it is continuous. This is very important. Okay. Okay, we have a data. Our data, it has some inputs and it has an output. The output is not discrete. It could have unlimited values. It is continuous. For example, if we want to predict the price of a product, the price of the product is a continuous value. It could be any value. Okay, so this is a regression problem. Regression means that we want to learn uh, an output which is not discrete. If it is discrete, it would be classification. For example, in the examples of classification, we had the family car and the non-family car, only two situations. But when we say we want to learn about the price of the products, we want to predict the price of the product. Okay, we want to build a system, a data mining system, for predicting the price of products in a supermarket. Okay, this data mining system, it would be a regression. Okay, do you understand this? No problem. One good example about this regression is the the price the uh, price of a house. Price of a house. Okay. Okay. When somebody wants to buy a house. Okay. Uh, if we want to predict the price of a building, a house. Okay, a building. The price of a building, it has continuous values. It could be anything. Okay, the number of values are not limited. It could have any value. The price. Okay. For example, if you want to buy a building, if you want to buy a house in Iraq, okay, the the prices of the houses, it could be anything. Okay, and they are different. It depends on the age of the house, the place where it is, and the features that the house has. Okay, it has different prices. So the price, it could have any value. But in the classification, when we say that we want to classify the fruits only have two types. For example, apple and pear. But here the price any has many values. It could be anything. Okay, the price could be anything. So we have a data, for example, we have a data about the price of houses, and each house, it has some features: the address of the house, the number of rooms, the options, the age. These are the features of the house. And then we have a price. Okay, in the learning, when we want to predict the price of a house, we have to find a relation between the price and the features of the house. Do you understand this? So in many problems, in many of our problems, we want to learn something which is not discrete. This is regression. Yes, a regression is supervised learning. Supervised learning means that uh, in this type of learning, we have the outputs of our data. This is what supervised learning is. Supervised learning means in the learning, we have the inputs and the output. If we don't have the output, it is not supervised learning. Okay. In in regression and classification, in both of these two learnings, we have the outputs of data, so it is called supervised learning. Okay. Okay, regression. We have many types of regressions. Okay, in the classification, we talked about the neural network, we talked about the convolution neural network, we talked about the decision tree, and we talked about the KNN. All of these were classifiers, but all of these could be used for regression too. Okay, so we could use neural network for regression. We could use KNN for regression, but the algorithms are different. They have some differences. When we are using KNN for classification and regression, there are some differences in the KNN, but it could be used. The same logic we have uh, for the regression and the classification of the in the KNN or in the neural network, okay, it could be used for regression. Or the convolution neural network, it could be used for regression. Also, the decision tree, it could be used for regression. Okay, almost all of the classifiers, they have the regression versions too. Okay, this is a point about regression. Almost all of the classifiers that we have, all of them, they have regression versions too. So regression is very popular. Okay, and uh, so it could be used. Okay, so we said that regression is a type of learning which uh, we could use, and the output is continuous. Okay, I want to talk about the linear regression, which is the simplest type of regression. Okay, have a 5-minute break and I will talk after. Thanks. Okay, sorry. Do you have my voice? Okay. Uh, the simplest type, the simplest type of regression is a linear regression. The simplest type of regression is linear regression, and in this regression, the learning model is like this. Okay, y is equal to w 0 plus w1 x1, w2 x2 plus wn xn. So the learning model is a linear learning model. It is something similar to the learning model that we have in the perceptron classifier. If you remember, it was something like this. Okay, the perceptron classifier had a linear learning model. In the linear regression, okay, we have this linear learning model. This y is continuous. In the classification, this y was not continuous, it was discrete. But here it is continuous, and okay, we have some features which are x1, x2, xn. Okay, so this is a linear regression. It has a linear learning model, and here we have the output y, which is continuous. Okay, uh, in this regression, similar to the perceptron classifier, learning means adapting the weights. Okay, we are adapting the weights for the learning. Okay, w0, w1, w2, wn. In the learning of the the linear regression, we want to set the weights. Okay, if you remember, we said that in the classification, we said that we have a learning model, and in the learning and in the training, we want to set the unknown values of the learning model. In this learning model we have here, the unknown values are w0, w1, w2 to wn. Okay, no problem. Okay, for the linear regression, we have many learning algorithms for the linear regression, and one of them is least square method. Least square method is an algorithm for learning in the linear regression. Okay. In this algorithm, in the least square learning algorithm, uh, we want to find a w. We said that the parameters in the learning model was w, and we want to set w. So we want to find the w that minimizes this error. This is the error. What is the error? The error is the difference between the target and the prediction. Okay, t means target, p is the prediction. Okay, in this summation, okay, we have the summation of from I equal to 1 to m, from 1 to m. M is the number of training data that we have, and we here we have some okay, this yi, it means the target value for the data I in the training data. Okay, for example, if I have 100 training data, for all of this 100 data I have a target value. The target value, for example, if I want to predict the product price, okay, I have some prices before. Okay, I have some products before, and I have built a data set. In this data set, okay, we have some training data and some test data. And in all of this data, I have the target. It means I have the price of each product. Okay. And uh, uh, yes, similar to T minus O that we had in the neural network. Here we have a different term, YIT minus YIP to the power of 2 here. Okay, so M is the number of training data, YIT it is the target output, and YIP it is the predicted output. Okay, uh, in this example you see that uh, if the simplest situation we could have in this algorithm is when we only have one input. If we have a data that only has one feature, x1, okay, so the learning model would be like this: y is equal to w0 plus w1 x1. Okay, so we have a data that has one input and an output, x1 and y. Okay, have here, okay, in this line, these are the errors: epsilon 1, error 1, error 2, error 3, error 4. These are the errors. Okay. Okay. We said that we have 4 training data: 1, 2, 3, 4. For example, in this data, okay, this is the x value here, and this is the y value here. Okay, x, y. And this line, in this line which we have learned using this data, it says that for this data, this is the y value. So this is the error, this is the prediction, this is the target. You understand? Okay. uh, in this uh, in this regression, okay, we want to learn. This is the learning model. Okay, this is the learning model. Y is equal to w0 plus w1 x1. Okay, in the learning, assume that we have this line. in the process of learning. Okay, and these are our data. Each of the data, they have x and y, and in the learning, in this line, okay, we give it the x and it gives us a y. Okay, if we give it the x here, this is the y. So for this x, this is the correct y, the target y, and this is the predicted y. So this is the error. Do you understand, Mr. Miss Hussein? Okay, thanks. Okay, so the error, would be like this. Okay, we want to find a line with these two parameters, w0 and w1. These two parameters, that this line wants to minimize this term epsilon 1, okay, epsilon 2 to the power of 2. These are the errors. Okay, epsilon 1, epsilon 2, epsilon 3, epsilon 4. Okay, we want to find w1 and w0 where these errors are being minimized. Okay, and to find these w0 and w1 in the least square learning algorithm, okay, it wants to find the optimum w0 and w1. If you remember, in the neural network, when we want to find the best weights, we use the gradient descent, and it was an iterative algorithm. But here in the least square, we don't use that algorithm, and what are we doing? We are taking the derivative mushtaq. This is a concept in mathematics. You know what is the but I don't want to go very deep into it. Okay, we take the derivative of the error and then we put it to 0, and then we say that w0 is equal to this term. Okay, so the algorithms for finding the weights, for learning the weights, are different. Okay, in the neural network we had the gradient descent. Here we have the least square. In the least square, we are taking the derivative of the error and we are putting it equal to 0, and then we are finding the parameters. This is w0, and again this is w1. Okay, we don't want to go deeper into this mathematics. No problem, and we won't have it in the exam. Okay, just the important point is that the algorithms. Okay, we have different learning algorithms. In the neural network, we had an iterative algorithm for learning the weights, the perceptron. Okay, you have read it for the exam, for the midterm exam. But here, the algorithm is different. It is using some mathematics. It is taking the derivative of the error, put it into 0, and finding the parameters. Okay, that's all we want to know about this. Okay, we don't want to go into the mathematics. Okay, no problem. So we have different learning algorithms. All of these algorithms have different strategies for getting the best parameters. Some of them are based on mathematics. Some of them are based on some algorithms like the gradient descent. In this algorithm, the least square is based on mathematics. It's based on mathematics. Okay, thank you very much. My subject is finished. I talked about regression, and I said that regression is a type of learning. The only point that is different from classification is that the output is not discrete and it is continuous. That's very important. Okay, thank you very much. If you have any question, please ask. Thank you very much and goodbye. خدا حافظ. التماس دعا.